Hi students. Okay, so where did we last leave off before the holidays? So take a look at topic 2 that we have covered so far for climate. So far you have learned about these various topics. Firstly, you remember learning about the natural variability of climate. You also learned about how the human actions actually cause climate change. So not just learning about how naturally our climate changes every 100,000 years and how human actions also cause climate change. We are also going to learn about different ways in which climate change affect our natural systems as well as our human systems. So far you had learned from the last time, you learned about the terrestrial systems, and today we are going to focus more on the aquatic systems. So these two will make up our natural ecosystems. Okay, so if I've covered this already in the classroom, just bear with me. You can skip ahead if you need to, but you feel free to listen on if I was going a little bit too quickly and you'd like to watch it again. Okay, so the last time before the holiday started, you had learned about how it affected our terrestrial ecosystems by increasing precipitation as well as decreasing precipitations in different places. Now, if this is unfamiliar to you, I strongly encourage you to go back and watch the video that I had uploaded during the last couple of lessons before the holiday started. Okay, so it would go more in depth to share with you why is it that when climate change causes increased precipitation, it leads to more flooding, it leads to more landslides, and it leads to more drowning. Similarly, when climate change causes a decrease in precipitation, it causes less rain. Why does it increase the drought? So this year you have to learn on your own, you have to revise on your own to be more familiar with this aspect of climate change on the impacts on the terrestrial ecosystems. Now, today we'll focus more on the aquatic and marine ecosystems by looking at how climate change affects our ocean. Okay, so please go and watch the video on Google Classroom because I would attach different videos to make it a bit easier for you to relate to the content. Okay, and I insist that you watch the videos because it is able to give you a little bit more in-depth information and helps to illustrate some of these concepts that are a bit more abstract in a more tangible manner. So please take some time to go and watch it during the lesson and ensure that you understand the concepts before moving on. Okay, so this here will be a video of a coral. It's a time-lapse video. So pause this particular YouTube video first to watch this attachment of what happens to this coral when it is exposed to certain environmental conditions in the ocean. Okay, so I'll pause for a moment and you'll come back and watch this in a while. Alright, so what did you observe? Okay, so what do you observe? What do you think had caused the corals to actually change from a very vibrant environment to something that's a little bit more dull and it looks a lot more lifeless, right? And I think by now you would know that one of the significant changes to our ocean is that the ocean actually, the temperature of the ocean increased significantly over the last couple of decades. Okay, so this is a graph that I believe that you would have a similar version of this in your textbook, and you have this exact graph in your SLS as well. So you can see that over the last few years, okay, from 1940s onwards, you can see that there's a significant increase, right? Okay, it looks very, very significant, but if you see on this side, okay, what is the temperature change? Okay, so something for you to consider. How is it that nearly 80 years had passed, but yet the temperature change is slightly less than 1 degree Celsius on average? Okay, so something for you to consider. So by now you would observe that the general trend is such that the surface temperature is increasing. Okay, and you have to ask yourself, why is it that this temperature is increasing? So we know that this coincides closely with the occurrence of greater human activities, more anthropogenic factors. So I hope you remember your, burning of fossil fuel, etc., etc. Okay, your agriculture, industrial activities, deforestation, urbanization, and so on. Okay, so all these produces a lot of greenhouse gas, and unfortunately, all this heat that is created by absorbed by the greenhouse gas, heat that is trapped by the greenhouse gas is absorbed by the ocean. And when the ocean absorbs this heat, why is it that the temperature doesn't rise significantly? Okay, so something to think about. Hopefully, by the time I show you the response, you will have some idea of why this may occur. Okay, so this here, you can see that the temperature increased just very slightly over 1 degree Celsius. And why so little? I want you to remember the different heat capacity, right, of land and sea, something that we looked at way earlier in our earlier climate chapter. So this is a very big clue. Why is it that it has increased so little? What about the ocean and its ability to absorb heat that caused it to increase very slightly over the couple of decades? Okay, while you consider that, let's very quickly look at the change in the surface temperature. Again, this here is a choropleth map, and they are showing you the different increase in the temperature. Okay, so this here is in Fahrenheit, but you can see here minus 0.5. This place became colder. We look for the parts that increased the most. This part will have increased the most. Okay, so some aspects here have higher temperature, but by and large there is a slight increase, right, throughout the entire globe. Okay, so this is in 120 years. You can see that while there's an increase, it's very uneven. Not all places experiences the same degree of change. So that's the meaning of it being uneven. And why does the change seem so little? So hopefully the clue that I gave you earlier gave you this hint that because our water here has a very high specific heat capacity, which means to say that it takes a lot for it to actually change the entire temperature of the ocean. So you have to imagine our ocean is really very deep, right? So in order for you to change its temperature, it requires a lot of heat because our water, because of the convection current, right, it takes a long time for the hot water here, the water of high temperature here, to actually cool down, and for it to actually cool down the entire ocean. Because of its huge volume, it's very challenging for it to actually change the temperature of the entire space. So in that sense, our ocean has a great capacity to absorb a lot of heat. But of course, we cannot rely on the ocean to be the one that absorbs all this heat, right? Because of melting of the sea ice and the other impacts on the ecosystem, which we will see in a while. So this here, while the ocean is able to absorb a lot of this heat, this is not what we want, and that's not the way to manage climate change. Okay, so what happens when the ocean temperature increases? So earlier when you saw the bleaching of the coral, this is what happens. Now the coral is a very unique organism, all right? So a healthy coral is one that has a close relationship with algae, and it depends on algae to survive. So what do I mean by this? Now, corals have a very symbiotic relationship with algae. So symbiotic relationship means that they rely on each other to survive. And algae over here, interestingly, is a food source to corals. So coral is actually a form of animal, okay? So it provides the structure for the algae to grow on. And the algae provide the food for the corals. And this algae here provides the color to the corals. So the very colorful coral reefs that you see is a healthy coral reef because the corals and algae are still able to survive well with each other, and they're able to thrive, and they are they show that they're healthy through their very colorful ecosystem, and they have a very rich habitat. It is a very rich ecosystem because it's a healthy habitat. But if the temperature increases, just like how you feel, when the temperature is warmer in the afternoon or during certain times of the year, you feel the heat stress, right? So even for humans, we experience heat stroke if the temperature is way too high. If we have a heat wave, we cannot manage the high temperatures if it's above, say, 40 degrees, for instance, for some places. So similarly for corals, they also feel stress. So if they are feeling stressed, what happens to these corals is that they will expel the algae that they rely on. Okay, so firstly, they expel the food that they rely on, and they expel the algae that gives them the color. Okay, so when they expel the algae, what happens then is when they lose the color, right, they will turn white. Okay, they lose their major or their primary source of food, And when we start seeing corals that are very dull in color, they're completely white, and that is when they become vulnerable to diseases and they are dead. So if this very rich habitat here becomes dead, what happens then? Okay, now I'm not sure how many of you watched this movie, Finding Nemo and then Finding Dory, right? But I would like you to just pause this video for a while just to watch the quick video that I've posted on Google Classroom. And when you watch it, take a look at the marine ecosystem that is in the coral reef. Right? What kind of animals are sustained by the coral reefs? What are the kind of animals that rely on the coral reefs for protection? Okay, so if coral reefs are bleached, okay, and they are completely dead, that is because of the temperature increase, and if they are bleached for a long period of time, it's very hard for them to revive themselves. Okay, I believe that I've posted another video for you to just watch and for you to have a little bit more information about the Great Barrier Reef, which is in Australia. So a lot of these aquatic species rely on the coral reef as a food source and a habitat, and if this dies off, the population will decline, and eventually this will affect the entire ecosystem. So you have to understand this concept of it being interconnected. All these species are connected to one another, and they rely on each other's survival in order for them to thrive. Just like humans, right? We also rely on our different ecosystems being thriving, right? In order for us to have our food source, for us to have a good habitat as well. Now, next thing, I want you to take a look at this particular picture. So, this particular picture, if you see this green aspects, green things on top of our river bodies or on top of our lakes, for instance, these here are phytoplanktons. Okay, so for oceans, you can imagine something similar. We have a lot of these phytoplanktons or algae, right? And this is what some of our bigger marine creatures, like some whales, for example, feed on. And all these algae here, they're very important because they absorb the CO2 that is produced, and they absorb this because they need it for photosynthesis. Okay, so they're able to take on some of this CO2, not just the trees that we have on our Earth's surface, but all these phytoplanktons and our algae is able to absorb the CO2 and store it within the ocean, so to speak. But therein lies a problem, okay? Because when our CO2 is absorbed by the ocean, then what is formed, right? So hopefully you still remember your science, your chemistry. What happens then when we have CO2 plus H2O? What is being created? Okay, so if your chemical equation works well, you should be able to calculate this. Right? And what's this? This is basically carbonic acid. Okay, so if I were to show you this here, you can pause this for a while to make a quick comparison. What are some changes? Right? You look at the thickness of the arrows, you look at the different components of the ocean. What happens then when we have more and more carbonic acid in the ocean? Okay, what happens to the pH? And what happens to these creatures in the ocean? Okay, so let me elaborate a little bit more. So when we have more and more carbonic acid in the ocean, this is what we call ocean acidification. Means our ocean become more and more acidic. So when our oceans become more acidic, and this is in fact happening, it has been increased by 25% since the Industrial Revolution, and this is from roughly this time period. Okay, and the problem with this acidic this increase in acidity, right, they react very well with calcium carbonate, which is what we can find in some of these creatures here. Okay, and these are the creatures that rely on our calcium rely on calcium carbonate to create their skeletons, their shells, and a lot of other animals feast on them. Okay, and importantly, because we have our coral reef is it's a very important habitat, right? And if they are not able to sustain themselves, it becomes a reduced habitat, and again it becomes a shrinking ecosystem. Okay, again, this is not healthy at all, and this is very dangerous. Okay, next part. Okay, so next change that we can see in our ocean. Okay, So this here is quite an interesting example. It's of course an environmental disaster. So in 1992, a cargo ship container tumbled into the North Pacific and it dumped 28,000 rubber ducks and other bath toys that were headed from China. So where do you think these rubber ducks ended up? It started off from China and it was dumped into an ocean. Where do you think these ducks ended up? Okay, interestingly, because they started surfacing on different parts of the Earth's beaches, right? So what happens is that the scientists were able to track how did these rubber ducks travel and what are the ocean currents that help to move these rubber ducks around the world. So very interestingly, this was what they found. So they started off from here in China, Hong Kong, China. You can see that eventually they started moving. They started finding them in different parts of the world and slowly across the different oceans. Okay, so the last one, the latest one that was reported was in 2007. Okay, nearly 15 years after. Right? So at this point, I want you to just pause this video and watch this first. What exactly caused these to move around? Okay, what are these yellow lines here? What is it representing? All right, I find that this video here is the one that is the most accessible one, the one that explains it the most clearly. So do pause this video first to understand what goes on. What exactly is the ocean conveyor belt? Okay, great. You had watched this. Now I would like you to watch this as well for you to better visualize the different warm surface flows as well as the colder subsurface flows. It's a very quick video. So pause this video again and go back to this. Now that you have a slightly clearer view, I want you to watch the very last one over here. Okay, so this here will have a little bit more in-depth description, but not to worry, I will summarize it and show you what are the essential concepts you need to understand. So please watch this third video on ocean currents before I carry on. Alright, so now that you have watched the very last video on ocean currents, let me show you. This is what you have on SLS. Okay, unfortunately, the one on your textbook is not the clearest, and while they had tried to darken certain ocean currents, it may not be the easiest to visualize. So I strongly encourage you to label and annotate on your own textbook. Okay, this might be a little bit more helpful, simpler, not so complex, so you can also draw something similar as this. Alright, so I find it useful for me to visualize the red one as the warm surface flow and the blue one as the cool subsurface, the deeper, cooler waters. Okay, so for us in Singapore, we do experience the warmer waters here, of course, because we are nearer to the equator, right? So we do experience warmer surface flows. Now, interestingly, okay, so how it should work is that we should have warm surface water that is moving from the equator to the poles. So you visualize this. So all these warm waters, okay, it will go to the different poles. Poles also include the South Pole as well as the North Pole, okay? So it's moving towards the different parts. I hope you remember why is it that our poles are of different, it is of colder temperature. Okay, if you forgot this portion, please go back to your topic 1 to revise how temperature decreases when it's getting higher in latitude. Okay, so coming back to this, as the surface water loses heat and it starts to cool down, salt is left behind. Okay, so when there's increased salinity, the density also increases. So the denser water will start to sink. Okay, denser water start to sink, cools down because it's further away from the surface, and it forms cool subsurface flows. Right? Eventually, because it is a current, right, convectional current here, what happens is that it will slowly rise back upwards towards the surface of the ocean. And the issue is when we have climate change, right? So climate change, what happens is that the water becomes warmer and warmer. Okay? So when the water becomes warmer and warmer, okay, gains more heat, it becomes less dense. Okay, and when it becomes less dense, the sinking of the water at the poles becomes reduced, so the ocean circulation becomes slower. And we don't want the water circulation to become slower. Why? Okay, because when the ocean water becomes slower, we have less of this movement. We want movements like this. So you can see this movement here, where the cooler water moves up towards the surface. This is what we call upwelling. You don't have to know this term, but you need to know that this process happens. So when this process happens, okay, it brings nutrient-rich water up to the surface. So this is not quite explained clearly in your textbook, so I hope you understand this component. Alright, so we need the cooler nutrient-rich water to come up to the surface, and this is a great area where people do fishing. So commercially, the fishermen will try to find places where there's upwelling, because the water there is very nutrient rich and you have better quality fish, for instance. Okay, so this is an area where it's very rich in the food web. Okay, so you have a lot more fishes, you have a lot more food available, a lot more nutrients available. However, when the ocean circulation is slowed down, okay, we have less of this mixing. The nutrients do not reach the surface, and then as a result, phytoplanktons, your zooplanktons that require all these nutrients to survive, they will drop in numbers, and the bigger fishes that eat these phytoplanktons and zooplanktons and so on, they will lose their food source. So when it loses the food source, this disrupts the marine food webs. Okay, then another issue is that when we have warmer and warmer waters, the animals want to try to survive, right? So what happens is that when you have warming waters, your animals will also try to move polewards. Polewards means it is moving towards the North Pole or the South Pole, to places where there are cooler waters. So that means to say our equatorial region, that is the warmest, right, will be moving towards the mid-latitudes, and those that are of the mid-latitudes will move to somewhere colder. So that also means that this area will have fewer and fewer biodiversity. And the areas that are in the poles will experience an increase in biodiversity. Okay, so we might be wondering, what is this very colorful fish here? This is known as a parrotfish. Parrotfish is really quite cool. You can go and read up or can watch YouTube about it. A single parrotfish here can contribute over 1 ton of sand annually. So they are very important to have a healthy beach, okay, because they replenish the sand that humans take for construction purposes. So these parrotfishes are actually very important for our ecosystem. So what happens then? Now, if you are a fish that can adapt and you can move, you can migrate, then it's great if you're able to find a new habitat with an abundance of food sources. Then of course your population will increase. Okay, so the issue is that these parrotfish here are so good in adapting, and this rabbit fish over here, they're so good at adapting that they cause another species to decline. Okay, why do I say so? They're looking for abundant food sources, right? And they managed to find abundant food sources in somewhere else in Japan. So the fishes from the tropics moved towards Japan and they found kelp. Okay, so they survive very well on kelp. However, kelp is actually a form of food and a form of protection for other species. So as a result of that, the other species face a decline. So that's really very unfortunate, right? So the adaptation of one species could cause actually the endangerment of another species. What about animals that can't migrate, or creatures that can't migrate, can't adapt well? So the classic example would be this here. Okay, so what we are seeing here, I hope you recall from the very start, this is our coral and it's experiencing chloral bleaching. Okay, which is to tell you that the algae has abandoned it, it's very stressed, it's not able to rely very much on the algae for a form of food source, and it's losing its color. So you can see that in this area, the aquatic species that cannot adapt and cannot migrate, they may face extinction. Okay, because the location is no longer suitable for them, and the animals around it that relies on it for a habitat or food source may also become extinct. Okay, so I would like you to think, right? How does the increase in greenhouse gas in our environment end up affecting our aquatic ecosystem? That is the main big idea for today. Okay, and you are to complete this understanding by completing the mind map that is available in your handout. So if you're able to consolidate all these different ideas together, pull these different sources of information together, and that would help you to fully understand the topic of 2.3, which I think is a little bit more technical and requires a little bit more scientific conceptual understanding in order for you to explain the impact and the process as well as the causes. So these three in the textbook, the organization is a little bit messy. I find it a little bit harder to see the connections between between each of them, which is why I think a mind map would be critical for you to consolidate your different ideas and to put it all together. Okay, so I hope that this has been helpful, and if you have further questions, please feel free to reach out. Okay, thank you.